Hello and welcome to another episode of Carbohydrate discussion series. Today I will present Thiocrown ether reversing SN1 to SN2 pathways in 1,2-cis Phosphoryl Glycosylation. Let's begin the session. So today I will present Thiocrown ether reversing SN1 to SN2 pathways in 1,2-cis Phosphoryl Glycosylation. So this one paper I will present where Thiocrown ether reversing SN1 SN2 pathways they have shown, and they have shown the how this reaction will undergoes to 1,2-cis Phosphoryl Glycosylation. So before going to the paper, they have mentioned in the abstract some challenges and their approach and applications. Here challenges are, so generally we are getting alpha and beta mixture of compound in case of phosphoryl glycosylation. And their novel approach they have mentioned over here, they have used the Thiocrown ether catalyst, where they are getting alpha as a major compound, and they have mentioned some applications like synthesis of 6 and 3 UDP glucose and Haemophilus influenzae CPS fragments. Now, there are some natural products which are having this this phosphate linkage, glycosyl phosphosaccharides. Where glycosyl phosphosaccharides contain phosphate group in their backbone, the anomeric position of one sugar is connected to the another via phosphodiester linkage. For example, this lipopolysaccharide where this C1 having this phosphate group, C1 carbon, and this C4 carbon of the another sugar having the phosphate group. And another example is capsular polysaccharide, Haemophilus influenzae type F, where the C1 having this anomeric position having this phosphate group and it is attached to other saccharides. Basically, it is a polysaccharide. So in the nature, basically, glycosyl phosphosaccharides exhibit 1,2-cis configuration, which is synthetically challenging. So getting 1,2-trans configuration is easier than the 1,2-cis configuration. For example, 1,2-trans like here we can see this is 1,2-trans, where this one is a beta and this C2 carbon is at equatorial, so it is called as 1,2-trans. So while here getting as alpha, that is 1,2-cis. So it is difficult because generally we are employing the neighboring group participation of this C2 group, so which provides the 1,2-trans product, not the 1,2-cis product. Now there are some previous work, like first method is phosphoramide method for the preparation of these phosphoryl glycosides, this phosphate group with the leaving group, and base they have used. So here they are getting at OH, they are getting this phosphate, and with another saccharides, another sugars, again they are doing the same reaction. So, and after the oxidation, they are getting this phosphoryl glycoside. But this condition have some cons and some pros and cons, like they're giving the high yields, but there is low selectivity and undesired oxidative cleavage after this oxidation they're getting. And there are other methods like H-phosphonate method and phosphoric ester methods. Those are also giving the same type of compound, but again there is a disadvantage, like they are giving the low selectivity. They are not getting one as a major compound, and they are giving the moderate overall yields. So basically, their stereoselectivity is based on the substrate-based stereoselectivity, and they have used the harsh conditions, and they requires multi-step reactions for this case. So that's why, for example, this coupling reagent, this phosphoric ester method, here they use the coupling reagent. So first saccharide will form monosaccharide, then again reacted with the same coupling reagent and sugar, they are getting this disaccharide. There are some glycosylation methods. For example, this glycosyl donor and this phosphate acceptor they have used. Promoter in one step, they are getting this compound, glycosyl phosphoryl glycoside. But in this case also, this reaction following the SN1 and SN2 pathways. For example, this leaving group is alpha, so they are getting alpha beta mixture. So they are following SN1 as well as SN2 pathways, and their selectivity basically depends on the substrate. And this reaction shows acid promoted conditions. So what acid will do is Lewis acid condition, which would hydrolyze the phosphodiester. That means final compound, expected final compound will not be observed. So in this work, they have used this Thiocrown method to overcome these cases and to get the high 1,2-cis selectivity. So their work shows Thiocrown ether assisted SN2 pathway which giving the high 1-to-6 selectivity, good yields, broad substrate scope. They have used the mild reaction conditions, and these reactions are the scalable reactions. So here they have used this glycosyl chloride, this beta glycosyl chloride as a donor, this phosphate acceptor. So without C7, but what is the C7? Here they have mentioned the C7, this crown ether, which having a mixture of this thiocrown ether, we can say, is sulfur and oxygen, which can coordinate with the silver group. Like whatever silver salt they will use as a promoter, they are coordinating with that one, and they are getting this alpha glycoside. And without C7, they are getting as a beta glycoside as a major compound. And other also they have mentioned other ligands they have tried. This one is not working with the only oxygen, that is not properly coordinating, so it is not working. Another with only thio compound, they are showing the poor solubility with the solvent, so this is also not working. So they have worked with this mixture of thiocrown ether. Now SN1 and SN2 pathway. Now we'll discuss with thiocrown ether what is happening, and without thiocrown ether how the reaction is going on. So first we'll see without thiocrown ether, which is normal, we can say the Koenigsegg glycosylation with this beta glycosyl chloride with in the presence of silver oxide as a promoter. There is removing of this chloride, like there is formation of oxycarbonium ion, and simultaneously this neighboring group will participate in the removing this chloride. So there is formation of this dioxylenium ion. So after once the dioxylenium ion will form, then this phosphate acceptor will attack. Now there is only one possibility for attack. It can attack only from the above side, because below side is already protected one. So it will attack from above side, and those are following the SN1 pathway, and they are getting beta glycoside as a compound. So this one pathway for the SN1 pathway without thiocrown ether. Now with thiocrown ether, what is happening? So everything is same, like we are getting the beta glycosyl donor in the presence of silver oxide. Now in this case, they have added thiocrown ether. So what thiocrown ether is doing? Thiocrown ether is coordinating with this silver salt, silver oxide. Then there is formation, this chloride will again coordinate with the silver. So there is associative intermediate will form. So in this case, there is no first removing of the chloride, and then there is formation attacking of the acceptor. But there is this transition state will form, where simultaneously this breaking of the chloride group and forming of this alpha side, forming of this acceptor bond. So it is SN2 pathway, and then there is giving the alpha compound, alpha glycoside as a major compound, and removing of the chloride at the same time. So the two SN1 and SN2 pathways we have discussed. Now optimization of reaction conditions. They are giving this beta glycosyl chloride as a 2 equivalent, then this phosphate acceptor 1 equivalent, silver salt they have tried multiple salts like silver carbonate, oxides, then crown ethers they have tried about to 9 crown ethers they have tried. Solvent they have taken as MTB, methyl tert-butyl ether as a solvent they have taken. 4 Armstrong molecular sieves, room temperature they have tried this reaction. So they compared basically yield between 9 alpha, 9 beta. Alpha and beta they have mentioned over here. So they started the screening out the silver salts, silver carbonate, silver oxide, silver acetate they have tried in the same solvent. So they are getting 67, 70, 68% yield, which are good yields. But the selectivity, they are getting beta as a major selective, more selective, 1 as 6. So they started with the crown 1, crown 2, 3, 4, 5, 6 up to 9. Crown 1, structure of crown 1, 2, 3, you can see at the last of the slides. This here you can see the structure of the compounds. Now when they have tried the crown 1, so there is alpha beta as a 1 as 1. So there is something possibility they can modify the crown ethers, and they are getting the more alpha compound. So here they got something. Then they tried with the crown 2, 3, 4, 5. In the case of 5, again they are getting they got the same condition, like 1 as 6, beta as 6, and 1 as alpha. That's why this crown 5 is ineffective, because no effective binding with the silver. Then they went further for the 6 and 7. In the case of 7, they are getting good yield in case of alpha, like 5.5 as 1. Then 8 and 9 also they have tried. So in the case of 7, they are getting the good yield in the case of alpha. So they increase the equivalents with crown 7, 2 equivalent they have taken. They are getting 7 as 1. Then 3 equivalent, they are getting 10 as 1 yield. Then again, they went for the crown 7 as a 3 equivalent. So their 3 equivalent, they are getting 10 as 1. And in last, like optimized condition, they have used crown ether 3 equivalent, silver oxide and IBO, isobutylene oxide, as a acid scavenger basically. So this isobutylene oxide 2 equivalent they have used. It is act as an electrophilic trap, which results in the alpha only glycoside formation. Excellent dry stereoselectivity they are getting 20 as 1. That means alpha as a major compound they have taken. Now reaction scope of donors. Different types of donor they have tried. Like with crown 7 they have tried. They have taken the yield of these compounds like alpha and beta. Without crown 7 also they have tried. So in the crown 7 they are getting SN2 pathway. Without crown 7 they are getting SN1 pathway. Here alpha glycosyl chloride they have used, phosphate acceptor. One side they have given the silver oxide MTBE 4 Armstrong molecular sieves, room temperature. Another side they have mentioned silver oxide crown 7 ether IBO. So these two conditions they have changed. Other things are same. So when they are using crown 7, they are getting only SN2 pathway, only alpha compounds you can see over here, like this acid, then this galactose, like deoxy sugars also they have tried. Then different protecting groups also they have tried. Here they are getting alpha as a 20 as 1, and with crown ether they are getting 1 as 4. So multiple donors they have tried over here, and they have checked the difference between with crown and without crown ethers. Now reaction scope of acceptors. So here glycosyl chloride, then phosphate acceptor, and all other conditions are same. They are getting alpha glycosyl phosphosaccharide, and after sodium iodide and acetonitrile, they are deprotecting this benzyl group basically, and there is formation of it as a OH. So as acceptor, they have tried different phospholipids, and donor they have tried like glucose, xylose, and glucouronic acids. So phospholipids they are getting only alpha compound. If you check this chart, there is only alpha compound they are getting, and they have tried with again with the different types of phosphosaccharides like C6. There is phosphate group with a different protecting group and different sugars they have mentioned over here, and in all the cases they are getting only alpha compound. With this acceptor they have tried these donors. Then again C4 there is phosphate group, C4 phosphate group as a glucose, then galactose. Then again in the case of C3 phosphate group, they are C4 phosphate group again they have tried. Then C3 phosphate, then at C2 position. So many phosphate acceptors they have tried, and in all the cases they are getting alpha only compound or silver salt 1.5 equivalent, crown 7 as a 3 equivalent, isobutylene oxide as a scavenger they are taking 2 equivalent. Now they have mentioned some synthetic applications. So in this case, gram scale synthesis of UDP6 and 3 glucose they have tried. In the case of 2,6 lutidine and triflic anhydride, DCM in first step. Second step is this TBAN3 in the presence of toluene. So basically by these two step there is formation of this azide at C6. Then in the presence of PCl5 and BF3 thread, they are getting our glycosyl chloride, and again glycosylation reaction, which they have mentioned in this paper, dibenzyl hydrogen phosphate as acceptor, silver oxide crown 7 IBO they have used, and they are getting this alpha compound, alpha glycoside. Then sodium iodide, acetonitrile, sodium thiosulfate, sodium bromate for overnight. So this condition they have used for the debenzylation. Another case, ammonia H2O. This condition they have used for the deacetylation. So they are getting here unprotected sugar now. And UTP at USP, tris Mg2 plus. Basically this enzymatic reaction, and they are getting this final compound as UDP6 and 3 glucose. So first application they have mentioned over here. Now second application, chemical synthesis of capsular polysaccharide repeats of Haemophilus influenzae type C. Here they have taken this 39 compound. again PCl5BF3 for making the glycosyl donor. And second condition glycosylation they have mentioned in this paper, dibenzyl hydrogen phosphate, silver oxide, crown 7, IBO. So they are getting this alpha phosphosaccharide. Here alpha linkage you can see. Hydrazine acetate they use in second step for the deproduction of this levoleucinate ester. And in the next step again this group is deprotected. So benzyl diisopropyl phosphorimidate, BCI acetonitrile, this tertiary butoxide, then triethylamine. So these three conditions they have used to add phosphate group over here. At this OH, there is phosphate. You can see in the next step. This 42. Here phosphate they have attached. And the same condition they used, PSCl5BF3 thread and glycosylation, normal glycosylation methods, whatever they have mentioned in this paper, they used. So 39, they have taken this compound and they again attached the phosphate group at this position. And they did the glycosylation with now this 39 and this 42. So this OH is free as an acceptor and this one is act as a donor. So they are getting this 43 as a compound, and with sodium iodide again they deprotected the R group. Here is the R group. So here is again formation of H. So 43 the B as a final compound they get. Now mechanistic study in this case. So basically all the reactions they have shown with the beta glycosyl chloride, and they are getting alpha as a major compound. Alpha is a major or only compound they are getting. Now they tried the beta glycosyl chloride as well as alpha glycosyl chloride. So in the beta case, they are getting alpha as a compound. So in the alpha case, they should get the beta as a compound. Then only it is considered as a proper SN2 pathway. So first reaction they have tried. Same condition they have used for both the glycosyl donors, and they are getting, when the beta glycosyl donor is there, they are getting alpha compound. And when alpha glycosyl donor is there, they are getting beta glycosides. That means this proved that this reaction is following SN2 pathway. Now another case, another reaction they have tried to rule out the orthoester effects. They have used 2-fluoroarabinofuranosyl bromide with and without crown ether. So first reaction they have tried with the without crown ether and their proper conditions. So they are getting mixture of alpha beta. Beta is 1.7 and alpha is 1. Another case, they have tried their conditions crown 7 ether. In this case, they are getting only alpha. That means there is no role of the C2 group. No, there is orthosubstituent effect is not observed over here. Now again, they have tried in the case of these NMR studies also they have mentioned. Here they have used silver acetate as a salt, then crown ether. This compound they mentioned. In first NMR, there is only this 18C compound. This NMR they have shown over here. And this alpha, this beta hydrogen is coming at 5.78 to 5.76. Now they mixed this 18C plus silver salt. Here they are not getting any change with this beta hydrogen, like 5.78 to 5.76. That means there is no any coordination between 18C to silver salt because of the poor solubility of the silver salt. Now they added the crown ether, where because of this crown ether, the silver salt is properly soluble, and now there is proper coordination between this chloride and the silver salt. So which they have mentioned because there is a shift in this beta hydrogen. This 5.78 shift to 5.81 and this 5.76 shift to the 5.79. That means there is coordination between this glycosyl chloride and this silver salt because of the crown ether. It shows that they interact with each other, and this reaction is proceed through the SN2 pathway. Now why there is downfield shift? Because there is electron shift from chlorine to silver. So it is undergoing for the decreasing the electron density towards this hydrogen, and it undergoes to the downfield shift on the NMR. So at the last, in concluding, they developed the crown 7 mediated conjugation or glycosylation operating via SN2 pathway. Crown 7 binds silver to form active silver crown 7 complexes that engage the glycosyl chlorides. This interaction forms associative intermediates enabling 1,2-cis selective phosphosaccharide formation. This crown 7 shifts mechanism from SN1 to SN2, avoiding acid-base working at room temperature. It enables the synthesis of 54 glycosyl phosphosaccharides they have mentioned in the paper with broad donor and acceptor scope with high stereoselectivity. Method successfully applied to UDP6 and 3 glucose and tetrasaccharide diphosphate from H. influenzae type C. It provides general mild strategy for accessing complex labile phosphoester linkages in glycobiology. Thank you.
Good presentation, Mahesh Bhaiya.
Thank you.
My question is related to what is the role of ground ether here, because normal silver also can chelate with the halogen. So in mechanism also they are not showing any role of this.
Okay. So crown ether role they have mentioned over here with crown ether, without crown ether.
No,
So
but
you're
they are showing
you're
role with
saying
only silver, not any effect on the selectivity. How is selective only help this SN2 reaction? Because
okay.
it is
Okay, so what they have mentioned over here, silver is act as a promoter. There is no problem in both the cases. It act as a promoter. Now they are little bit decreasing the strength of silver. For example, if only silver is coordinating with the chlorine, then there is faster reaction and chlorine will remove easily. It will remove easily and formation of oxycarbonium ion first, and then the reaction will go through the mechanism. Now the silver strength is reduced because silver is now not coordinating only with the chlorine, but it can coordinate with the thioether also. So there is less chance for chlorine to remove out. So there is simultaneous breaking of this chlorine bond also and adding of this acceptor also, because now more strength is now not available for this silver salt. That's why this glycosylation they have mentioned not the less time. This glycosylation they are doing at least for about 24 hours. They have mentioned in all their reactions 24 hour, 48 hour like that, because of their reduce the strength of silver salt.
okay.
Hmm.
Okay, Bhaiya. Thank you.
Yes.
Nice presentation, Mahesh.
Yes.
So I have only one question. So since this method, from this they are basically showing that this chloride can be activated in SN2 fashion, right? Selectively.
Yes. Yes.
But here every time they are using this phosphoester acceptor. So that is showing the
Yes.
selective formation of
Yes.
phosphoester. So they didn't try anywhere to form the ether linkage, like whatever we are doing for glycosylation, normal O glycoside.
Yes. Yes. Yes.
From beginning, they have targeted that only, or like somewhere they might have commented anything based on the nucleophilicity or something. Why?
Nucleophilicity of the acceptor, actually, they have not mentioned anything about it. They only targeted only one acceptor, like phosphate group as acceptor, and they are getting selectivity only this case. They have not tried any other acceptors.
Yes, because that's why in all sugar also basically they are making this phosphodiester linkage if they are using sugar in that case.
Yes,
So
yes.
basically if you'll see, then
Hmm.
acceptor is kind of same only, that phosphate acceptor.
Yes, yes, yes.
So I don't know if similar method, if whatever mechanism they are proposing, I feel like if that is the way, then it should work for the ether linkage also. Until unless there is a rule of some like balance of nucleophilicity is there.
Yes. If there is a role of the thiocrown method, it should work in the other acceptors also. Yes.
Yes, I feel so. So there must be something they might not have mentioned there.
Or
But
maybe there is combination of this thiocrown ether only or phosphate only. Maybe they are fitting to this condition. Okay. Only
yes,
phosphate is act as. Hmm.
I feel like there may be some balance is there, because obviously
Yes.
before that this
Hmm.
phosphate uh, group has been used in glycosylation as in donor, like we are using TCA, people will make phosphate, like in sialic acid, we'll see they will make this phosphate and then it has been activated further towards glycosylation. So obviously it has some different role and in reactivity also. But here I feel like somehow the nucleophilicity is balancing out and it is merging with the chloride substitution. That's why.
Yes.
Otherwise, maybe you can see the same group whether they have published in some different paper or not using this. And
Maybe that can be also possible that one target
maybe
they did like this or
they might
another.
have done it.
Yes. Yes. Yes.
Other than that, it is good paper. Nice work, nice presentation.
Yes.
Thank you.
Hello. Nice presentation,
Yes.
Mahesh.
Yes.
So my initial question is like, this glycosyl halide they prepared, na?
Yes.
Initial restart method that is everywhere it is beta only since their substrate is beta. So, how about the cell like means when you do the conical glycosylation with halide? So how much is the when NGP is there any like how much percentage they will get beta because alpha is more favorable, right?
If NGP is there, then they are getting
Hmm.
completely beta. In first slide also they have
Completely beta.
mentioned. Yes. Here they have mentioned.
Okay,
So
okay.
only beta they have
No,
shown,
no,
not
no,
the
no,
weekly
no,
table.
not about this one, not about this one. The formation of glycosyl halide itself, I'm telling.
Oh, okay. You're telling about
Uh-huh.
this one, like
Maybe,
formation of itself.
yes. Because if I'm not wrong, even if you have NGP, because of your anomeric effects,
Yes.
the alpha halide should be more prominent. But
I
here
think they
they
are
are getting,
separating.
so that's
For glycosyl chloride, they use like PCl5 and BF33. BF33 for activating these acetate and
okay.
PCl5 as the chloride donor. Chloride, like they are providing. So I was also getting the same question because in anomeric effect, generally we are getting as alpha here. If there is some chlorine or
True,
some bromides
true.
are there, only alpha will be
Uh,
there.
uh,
But in this case, they have mentioned only, not only, I can't say only actually, they have not mentioned about this one. Maybe they separated or what they did. Actually, I don't know.
Maybe they have mentioned in supporting
Supporting
information
information.
somewhere
Yes.
must be missing. And you
Yes.
go to slide number 10. If you here in the first line, the last reaction, removal of BN group, it is sodium iodide and acetone nitrate with 6 degrees Celsius. So why I came to this
Yes.
one means I also did one. I was supposed to do this reaction. And Bharat Bhaiya, I don't know what was the update. What is the update of that reaction now? So he was also in one of the step he had to do the debenzylation. That he thought of doing it. What is that? Hydrogen peroxide charcoal hydrogenation. But this reaction look different. I don't know whether it should work. It will work only with the phosphoesters or it will work with all BN. But it is something different reaction. That's why I thought of asking.
It is Finkelstein reaction. Finkelstein, like iodide will attack on this oxygen. SN2 kind of
Okay.
reaction, oxygen. And this benzene will out.
Okay. So that works like that.
I have
Yeah,
checked in the internet, so it is working like that.
okay.
But I don't know, after that reaction also they have used sodium thienosulfate. If we are going on this slide, this first step
Uh,
is sodium iodide acid nitride.
uh,
And again in second step they use sodium thiosulfate plus sodium bromate, which is also another debenzylation method.
that is very much of obvious our as we have seen earlier also that is one of the method of debenzylation. Or is
Yes.
there also they have this step they missed the mentioning?
They are not
No, I
mentioning
think
anything, but two methods. Why they are using the two methods? If this sodium iodide is working, then why you are using the
okay.
second debenzylation method again?
True. So that is something looking very fishy here. Like here also that is just a BN group removal
Two BN groups are there.
to BN group, and there is also. And you see here they removed acetate group just with ammonia water.
Ammonia water, yes.
Oh, this also works.
Hmm.
Okay, in that case, we can try this one if our molecule is very much stable to the sodium methoxide because it can go to the little higher pH, but
Hmm.
ammonia will not go to the higher pH. That time, if you want, we can try this one. During, let's say, in one of the TF antigen synthesis step, one of the step is there you have to control pH. So this also can
Yes.
one of the thing we can do. So in the last step
Hmm.
here from 37 to 38, it is like enzymatic glycosylation. This one,
Yes.
UTP.
Yes.
Okay,
Hmm.
enzymatic reaction. Okay, thank you.
Yes.
Yeah, nice presentation, Mahesh Bhaiya.
Thank you.
I have a little confusion in your NMR slide. Please go to
Okay.
that slide.
Huh.
Uh, like here, you are saying something about shifting. Can you please explain again?
Okay. So first they have mentioned this. They are taking different types of NMR with different compounds they have read. Only 18C they compound mentioned this first NMR, where this beta hydrogens value they have mentioned 5.78 to 5.76. This beta hydrogen.
Okay.
Now another case they are adding the sugar plus the salt. Basically, so they are again getting the same values 5.78 to 5.76. And in third
Okay.
NMR they have mentioned they are adding now 18C sugar plus salt plus ground ether. So they are using, I think, one particular solvent. Whatever you are saying, I'm understanding one particular solvent they are using, and in that solvent, this salt plus thiocrown ether. So this thiocrown ether make it soluble in the solvent, and then it is coordinating with this chloride. And because of this coordination with the chloride, that hydrogen will undergoes to the downfield shift because electron pull is there, electron shift is there. That's why it is undergoing downfield and formation of 581 to 579 ppm values, like it shows.
And what this 4.5 is coming peak?
4.5. This one?
I thought earlier I thought that this belongs to anomeric hydrogen.
No, no.
So this belong to which carbon?
I think any
This
other skeletal hydrogen maybe that is belongs to, but it is not belong to the alpha, like sorry, not alpha, anomeric. Anomeric
anomeric.
hydrogen they already mentioned over here, 5.81 or
It's
something.
coming 5.8.
Hmm.
Okay. 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 Thank you.
Nice presentation, Mahesh.
Yes.
I don't have any question now, but previous slide, as others has been asked already.
Okay.
So, like if you see like 36 to 37,
Uh,
in that case they use two step to remove the OBN group, and then
yes.
43, 43B, they use
Uh,
again only one. So just for one OBN is working. If there is two OBN, that means that condition is not working. It's
oh,
like that.
maybe because R is equal to OBN they mentioned, they differentiated this OBN with the another OBN. It is like that, maybe. But if you are saying like that, here also you see R is equal to O. Here also OBN is there, and this case also there is OBN. So these two OBN is going out. This one as well as this one.
So that means then why they use 36 to 37 two conditions to remove of the OBN group?
That is also another question actually. That is also. I am thinking on one.
Uh-huh.
I don't know, but these are two are the same. Like here also OBN, here also OBN. All the functional group is same. Everything is same. Conditions are same. So both should go actually undergoes to the reaction. Oh, I think it's Finkelstein reaction. So these I might will attack on the
Uh,
this oxygen.
if you see whatever etheric protection is there, like MOM, MEM, in that case, even PMB also, the removal group is working like that only. So like it will attack on the methylene carbon. So like whatever protecting group will be there, that will leave out. Mechanism is fine. I don't have a problem with the mechanism. Just Okay, here 2 obin is going. And the previous slide also, they've used the same condition. There was 1 obin. That was very much clear. Okay, if there is just 1 obin, then it's fine. It's working properly.
Okay, I'm getting like if on the same substrate, like one form, it
Uh,
did the mechanism same, did the reaction. So maybe in the second case, it is not working. I don't know. There is changing in the functional group right here. CH2. This will go out. I don't know exactly.
yes, yes.
Something is in the
And-
mechanism only.
Mhm.
Hmm.
And the next slide.
Yes.
Next, where you have shown the mechanism, how it's getting activated, like without brown ether or with brown ether.
Oh, okay, okay. Ah,
In this one. So once this silver is getting coordinated with the crown ether, so how much
yes.
electrophilicity of the silver is getting reduced? Maybe like it is still kind of electrophilic is activating the silver, or is completely whatever vacancy is there for the electron is getting from the sulfur itself. Did you get my question?
Like, can you
Like
repeat?
electrophilic, right? Kind of. So it's
Yes.
taking lone pair from the chlorine.
Yes,
Without crown ether
yes.
is fine.
Hmm.
With crown ether, since it's coordinating with the first sulfur, so now 3
Yes,
sulfur are there. Whatever vacancy
yes.
or the electrophilicity of the silver is there, that is getting fulfilled by the sulfur.
Decreased.
How
Yes.
much uh, electrophilic the sulfur after that is, because it's not very good leaving to be activating. Otherwise, it will leave. It will follow the SN1 pathway. Since it is just activating the silver, it's not that much
Yes, yes.
leaving group. It's not leaving itself. It's nucleophile. It will come. Then only it will leave. It is leaving.
So generally in our case, the normal Koenigsegg reaction we are trying. So we are keeping the reaction for overnight. Overnight, for example, 8 hours, we can say, or something like that. So in that case, reaction is working, right? Glycosylation is working. So in the same case, they have mentioned for 24 hour. I will show you over here. Here you can see 24 hour they are keeping reaction. Then they are getting these results. That means at least 3 times. I don't know exactly how much times, but they are decreasing the speed of the reaction as well, because it is not that much activating the chlorine also. So slowly, slowly this reaction is going on like.
Yes, yes, something like that. Otherwise, yes,
Yes.
because yes, availability of the silver as a electrophile is not that much compared to the without the crown ether.
Yes.
Nice mess. In the first or second slide, like still like getting 1-cis product of the glycoside is like still rare. It's still challenging. So like
Yes.
every time they have shown like 20:1, did they get the complete alpha with this one? Other
In optimized condition, they have shown like 20 as one. But if we are going for these donors, like different donors they have tried, so they are getting only alpha they have shown over here. You can see here. Here also they have shown only alpha. Only alpha. So many cases they have shown the only alpha, and some cases they have shown like alpha and beta. Here, for example, in this case, alpha and beta they have shown 20 as one.
maximum time they have shown only alpha here.
Yes.
Earlier. And also since their target was just to get this glycosyl kind of phosphate only. This is the whatever
Yeah.
natural occurring compounds are there. It's not like they are developing the kind of phosphate donor here.
Yes, yes, yes.
So they did not use as a donor till now.
No. They haven't used as a donor. They are only as a acceptor and formation of compound, final compound.
Because in nature also they are kind of phospho-linked glycoconjugates are there. They are just targeting that only.
Yes, yes.
Nice, Mahesh. Thank you.
Okay, thank you. If you enjoyed this session, don't forget to like, share, and subscribe.
We'll meet you in the next episode, next session. Thanks for watching.